circular functions. And the best way to show you is just, and I don't think there's that many, there's only 24, but a lot of it is just, again, stuff that you already know. It's basically, we're going to be talking about the unit circle. You're going to be forming the unit circle and putting in the cosine and the sine. Now, the reason it's opposite and you don't put the sine first is basically because of the way the triangle is turned. That's basically it. Okay, and I'm not going to derive why the cosine is first, but whenever you're doing the unit circle, the cosine is first. The cosine is your x coordinate, the sine is your y coordinate. And you're going to see in vectors, r sine theta is your y vector, or cosine theta is your x vector. So just bear with me, and the cosine will always be first. And of course, you see these 1, 0, 0, 1, and that's the unit circle. The unit circle has a magnitude of 1, just like the unit vector. The unit vector is a magnitude of 1. So I'm just trying to do a little bit of association here. And then, of course, you're in the middle is 30, 45, and 60. And this is just another way of writing your reciprocal of the sine. I'm not gonna go over that. Y'all know how to do that. Remember, calculators must be in radian mode when you're finding rotation, meaning radians. Right here, 3 pi over 2. Well, I'm gonna go ahead and tell you this. Probably the best thing for you to do is go to Google or wherever and type in unit circle. That's it, unit circle. And you might want to do printable. And here they are. And you just pick you out one. And I'm not saying learn, I'm not saying regurgitate. That's not what I'm saying. What I mean is get it, print it out, put it on a big index card or a placard to go on your front of your notebook or whatever, and have it. Okay, because you're going to need it. And here it is. There it is right there. That's a nice one to print out right there. It's got everything. It's got your sine and your cosine, your cosine and your sine. It's got your radians. It's got your degrees. So pick whichever one you want, but that's a good one right there. Because that's what basically you're going to be doing in 9.5. So let me get back to it. And I'm trying to find my PowerPoint. There we go. And there's that one, 3 pi over 2. 3 pi over 2 is 270 degrees. So you already know that your sine, your cosine is 0 and -1, just because that's how you plot 270 degrees. 0, -1. And if you did the sine of that, you would get -1, 0, and undefined. The reciprocal of undefined is 0, so the cotangent would be 0. The secant would be undefined, and the cosecant would be 2 over 3 pi or whatever, you know. I'm sorry, -1. So that would be -1. Cosecant is -1. Okay. Seven pi. Well, before I do anything, what is 7 pi over 4? 7 pi over 4 is your 45-degree angle. I was going to write 7 pi over 4. Hold on. 7 pi over 4 multiplied by 180 over pi. They cancel.
315 degrees.
Say again?
315 degrees.
Yes, because 4 will go into 180. Let's see, 45. And 45 times 7 is 315 degrees, which is your 45-degree angle here, which is 315 degrees from here. So this is your 45-degree angle. Now again, the reason I show this, I'm trying to get you as students to learn these things, not regurgitate. Okay? If you learn them, it stays with you a whole lot longer than if you just regurgitate. So I don't want you to memorize. I want you to, and that's why I always do this, to show you that you can always go back your way and find the angle and then associate it with your special angles. That's why I do this. I don't do it to take up time, and I don't do it to aggravate students. I do it to help the students that need it. Okay, so there's your 45. You know that this direction is the square root of 2 or the square root of 3. You know this is -1, therefore this is 2. And this is your man, and this is your opposite. This is your adjacent, and this is your hypotenuse. And of course, you can do sine Oscar had, so that's -1/2. Cosine a hunk, that would be square root of 3/2 of apple is going to be -1/3, which is negative square root of 3/3. Negative square root of 3/3. All students take calculus, so the cosine and the secant are going to be positive. And look, this one is positive. Now, does it take a little bit longer? Yes, it takes a little bit longer if you do it this way, but you never lose it. What happens when you memorize stuff? You lose it. If you learn it, you don't lose it.
Wouldn't the legs of a 45-degree triangle, wouldn't they be 1, 1, and then square root of 2 for the hypotenuse?
Yes, it would. Yes, it would. I'm sorry. You should have said something.
Yes, sir. I knew.
Sorry. 1, 1, square root of 2. I'm sorry. So that'd be 1/2. Oh, I'm stupid.
Tangent would be -1.
And then what?
Tangent would be -1.
Thank you. Okay. Thank you for catching that. All right. Anyway, so let me get rid of that mistake. Sorry about that. And that's what they're going to do with this example. Okay. And they're going to do the cosine and the sine or whatever, and they're going to there they are. Now, since we're putting the cosine and the sine on this coordinate right here, that's going to be square root of 2/2 and negative square root of 2/2. Cosine and the sine. All right. Okay, 5 pi over 6. If you do 5 pi over 6, 5 pi over 6, and I'm doing this again. I'm not doing it to aggravate you. I know some of y'all are getting aggravated, but please don't. 5 pi over 6, that'd be 180 over pi. And it's going to be 150 degrees because that goes out with 30. 30 times 5 is 150. 150 is 30 degrees from 180. So now you have negative square root of 3. Please don't let me screw this up. Positive 1 and 2. And the sine, remember, your little man is here. Opposite, adjacent, and hypotenuse. Oscar had, Sine is 1/2. Cosine, a hunk, be negative square root of 3 over 2. Of apple, be 1/2. Be the tangent. Okay? I'm looking to make sure I got my signs right. All students, that would be the sine and the cosecant. So this needs to be negative. That's not negative. All students take calculus. I guess I got something right. Oscar had a hunk of apple. Oh, square root of 3. There we go, negative, which would be equal to negative square root of 3 over 3. There we go. So on this spot up here on the unit circle, you would put the cosine, negative square root of 3 over 2, and 1/2. And that's probably what they're going to do. Negative square root of 3 over 2 and 1/2. Does everybody see where I'm going with this? Basically, you're going to fill out the unit circle. Okay? And I showed y'all this like the first week or the second week of class, the unit circle and how to not fill it out with sine and cosine or cosine and sine, but how to find your special angles. And they're still doing the tangent, but you really don't need the tangent with the unit circle. And graphing calculator, set your calculator to radians, and you can actually type in sine of 5 pi over 6, and you can turn it to a fraction like that, or you can have a decimal. Okay, we're just showing you there how to do that. So make a note of that, and take a picture of it or write a quick note, but you know, it does come in handy to be able to change it from a radian to a decimal or a fraction. Give everybody another few seconds to write that down. Remember, when it's in the calculator, it's approximate. When it's radical, it's exact. So if the directions ask for exact, you do the radical. If it asks for approximate, you do the calculator. And next, there is your unit circle. Now this one's a good one too. If you wanted to snip this out, snip it out, put it in a word processor, copy it, put it in a word processor as a picture, insert, and print it out and put it on an index card. Find the exact values of the cosine of 7 pi over 4 and the sine of 7 pi over 4. Well, I think we've already done this, but we'll do it again. Doesn't hurt, especially for those that suck at it. Doesn't hurt at all. So I'm going to take my handy dandy, I'm going to write everything down. I want the cosine of 7 pi over 4. And I want the sine of 7 pi over 4. And then they want the tangent of negative 7 pi over 4. And use a calculator to approximate cosine of 1 point to 4 decimal places. Now, I'm not going to do that, but I think you should be able to do that. I think they want it in radian mode, so I think y'all can handle C. But 7 pi over 4. And 7 pi over 4 multiplied or is equal to, or whatever, 180 over pi. And I thought we did this. That'd be 4, that'd be 45, which is 315. And 315 is going to fall right here. And hopefully I won't mess this up again. 1, -1, square root of 2. And we got a little man here, opposite, adjacent, and hypotenuse. So the sine, I'm just going to do all of them, or the first 3. Sine is equal to Oscar had, so that's going to be -1. It's going to be square root of negative, square root of 2 over 2. Cosine should be the same thing, but we'll check it. 1 over square root of 2, which is square root of 2 over 2. And tangent. Tangent of apple, so that's going to be -1 over 1, -1. Now, I don't know why they threw the tangent as -315, but we'll do that. We'll do that in another color. We'll do, we'll draw it like this and do the angle in red since it's negative. Well, that's going to be -315. Well, if this is positive, -315 would be right there. That's -315. And of course, this is a 45-degree angle. So this would be 1, 1, square root of 2. And the tangent, since your little man is right here, opposite, adjacent, Oscar had a hunk of apple, is equal to 1. So again, this is just a little exercise, or this right here is a little exercise. If you can, now there's 2 people. There's people that memorize this stuff, and there's people that learn it. And they're okay. Both of y'all are okay. If you're going, what do you do? How do you get 7 pi over 4? You know, if you're doing that, then we need to have a prayer meeting and we need to get you caught up. But hopefully you should be doing either memorizing it or you should be learning it. Okay. And negative square root of 2, square root of 3. I got the square root of 3. How did they get the square? Oh, that's 5 pi over 3. Wait a minute. Did I do something wrong? I must have copied it down wrong. Hold on a second. Yep, I sure did. Tangent of -5 pi over 3. My bad. -5 pi over 3. So I'll do that on another page. I'm sorry. I didn't take my medicine this morning. Sometimes I get things mixed up. Tangent of -5 pi over 3. So I'll do this again. Sorry. So -5 pi over 3, I'm going to find out where 5 pi over 3 is. 5 pi over 3, that's going to be 180 over pi. 3 will go in there 60. That'll be 300 degrees. I think, somebody check me, I think that's right. But it's negative, so that means I'm going to go this way, and I'm going to go here. And that means I've got a 60-degree angle. And my little man is standing right here. So I've got 1 square root of 3 and 2. And the tangent, Oscar had a hunk of apple. That's going to be the square root of 3 over 1, which is the square root of 3. So let's see if I got that right. Yep. Now, if you notice, they do it a different way. I don't do it a different way. I just do it where it is. Okay, so if you want to do it that way, you can, but I do it the way I take 5 pi over 3, I turn it into the degrees, I move it where it needs to be, and then I apply the positives and negatives to it. If I write down the correct problem. There is your cosine of 1.85. Make sure it's in radian mode. You might want to write this down because f of the moon is given by f of t is equal to 1/2 1 minus cosine of t, where t is called the phase angle. F of t gives the fraction of the moon's face illuminated by the sun. Bet y'all didn't know that. So if you want to know the phase of the moon, you just type in the cosine of t and subtract from 1 and multiply by 1/2. And that's a percentage. Evaluate each expression and determine the results. I guess they want you to plug in 0, pi over 2, and 3 pi over 2 and pi. Okay? So let's do that. I'll write it down. So f of t is equal to 1/2 times 1 minus cosine of t. And they want you to do f of o, 0, f of pi over 2, or of course pi over 2 is 90 degrees, or f of pi, which is 180 degrees, or f of 3 pi over 2, which is 270 degrees. Or is that 3 pi over 4? I can't remember. I always get them mixed up. I think isn't 3 pi over 4? Yeah, pi over 180 over pi, 3 times 270. Yeah. Okay, and plug and chug. Well, I'm going to show you a trick I learned in the war. Okay. Let me get back to here. Well, see, you know your unit circle. Your unit circle, remember the unit circle? You know that this is 1, 0. You know that this is 0, 1. You know that this is -1, 0. And you know this is 0, -1. And you know this is cosine and sine. All right? So if I want the cosine of pi over 2, then the cosine of pi over 2 is 0. Well, what about 0 here? Well, it's 1. No matter if you're at 360 or 0. So that's going to be 1. So it's going to be 1/2 times 1 minus 1. It's going to be 1/2 times 1 minus, what's the cosine of 90? 0. 1/2, 1 minus, what's the cosine of 180? -1. And what's the cosine of 270? 0. So 1/2, 1 minus 0. And that's going to give you 0, 1/2. 1 plus 1 is 2. 2 over 2 is 1. And 1/2 times 1 is 1/2. So the unit circle does come in handy because later on you're going to ask to find the cosine and the sine of an angle, and you're going to remember the unit circle. So let's see, where is that question we just did? There it is. So 0, that means a new moon. Next, 1/2, first quarter. 1, full moon. And the last one should be 1/2, last quarter. Of course, you don't need, this is an astronomy class, so we're not worried about you understanding about the quarter, the full. I understand it, but some of you may not understand it. That's not a big deal. I just want to make sure you can get that 0, that -1, and that 0 without having to use a calculator. Okay, the figure shows a function f that models the tide in feet at Clearwater Beach, Florida, X hours after midnight. So the tide's at between 2 and 3 feet at 4. This is after, for about 4 o'clock in the morning, about 8 o'clock in the morning, and it looks like it's lower and higher, lower and higher, and so on. Find the time between high tides. Well, high tide is 4 to what? Well, 16 hours, that's going to be what? 12 is 12 o'clock, and then, of course, 4 o'clock. So that's going to be 4 o'clock. And then, of course, 24 hours would be back. And then this would be 28. So that'd be 4 in the morning also. So 4 in the morning, 4 in the afternoon, and 4 in the morning, looks like to me. Oh, the time between. Okay. It's about 12 hours. And they were using the points. I was using the dots. I wasn't even looking at the points. Okay, so I was going from 4 o'clock to 4 a.m. to 4 p.m. to 4 a.m., which is basically 12 hours. And I was reading the graph. They were actually calculating. What is the difference in water level between high tide and low tide? Well, it looks like to me you got about 2.6 here and 1.4 here. So what is it, 1.2? They're just asking you if you can read a graph. The tides can be modeled by this. Estimate the time when X is 10. So we'll do that one because that's the only thing really pertinent to what we're doing right now. So f of X is equal to 0.6 cosine brackets 0.511 parentheses X minus 2.4 close plus 2. And they want you to plug in 10. So I'm going to plug in 10. F of X, f of 10 is equal to 0.6 cosine 0.511 times 10 minus 24, 2.4, plus 2. Well, that's going to be equal to 0.6 cosine brackets 0.511 and 10, that'd be 7.6. Y'all help me out there. Plus 2. And half of 7.6 is 3.8. So if somebody multiply 0.511 times 7.6, it's going to be around 3.8. What is it?
I got 3.8836.
3.8836. 0.6 times the cosine of that, and then add 2 to it. So somebody give me the cosine of, and I would put it in radian mode since that's what we're doing. Cosine of 3.8836. Somebody give that to me, please. And just take it to 3 digits. cosine of 3.8836. Do y'all have a calculator? I mean, do I need to do it? I guess I'll do it.
I got 2.5986.
Everybody got that? Or anybody else get that? Was that a yes or no, Mr. Parrish? Okay, y'all just not gonna talk to me today. That's fine.
I got 2.6.
You got 2.6 also?
Yes, sir.
Okay, we'll just multiply that 0.6 times 2.5986, 2.5986, and then add 2. I got 3.55916. 3.55.
Oh, I was saying that 2.6 was like the final answer.
Yeah, me too.
You said what?
I was saying that 2.6 was the final answer.
Okay, I didn't ask. Okay, I appreciate it, but I didn't ask for that. I asked for the cosine of 3.8836.
My bad. I'll get
That's
that.
all right. Let me go back and do it. Cosine of 3.8836. Y'all check to see if y'all got this. I got 0.9977.
Yeah, that's what I got.
So 0.6 times 0.9977 ... times 0.6 and add 2. Is that what y'all got? 2.598622224. Did y'all get that? 2.6?
Yes, sir.
Okay. Now, I can go ahead and tell you this. I doubt very seriously that I'm going to ask any of these. Okay, well, we didn't do something. They got 1.56. Oh, my calculator is not in radian mode. Mode, radians. That's why it's different. We messed up. Okay, now, cosine of 3.8836 multiplied by 0.6 and add that to 2. You got to watch it. There it is, 1.56. Okay, I doubt very seriously that you're going to see this on a test because it's a calculator drill, and most of you be able to do that. But you got to remember, it's got to be in radians. It's got to be in radians. And there's your right triangle ratios. I'm not going to get into that. That's it. I'm not going to get into those last 2 slides. Okay, so basically all I want you to be able to do in this section is give me the unit circle. Everybody good on that? Unit circle. So 9.5 is basically the unit circle. And let's see, where's 111? I've got a few more questions I haven't went over, so let's go over them just to help y'all out with the homework. All right, this is 9.41 / we might have went over these. I can't remember. 1/1. Please tell me if we went over them. Let's see, what's this one? Well, we went over that one, didn't we?
Yes, sir.
Okay. Next one, 9.4. That's the same one. Well, I usually delete them. Why didn't I delete these? Probably because the computer was acting up. All right, this is 9.4, 13/4. And this one hasn't been read because it's still bold. All right, this is one where you actually don't have a triangle to draw. You got to draw it. And C is always 90 degrees. So I'm just going to draw a handy dandy triangle. And this is angle C. So this is little c. Okay, they don't give you very much. They say solve the right triangle, ABC, where C is 90. Give angles in degrees and minutes. Traditionally, the one that's on the adjacent line is usually big A. Okay, I'm just going to go ahead and tell you that right now. And up here is big B. And this is little b, and this is little a. And they give us A, little a is 19.1. And little b, or little c, is 46.2. Now, I'm going to change my letters. I'm going to change this to adjacent, opposite, and hypotenuse. That's just the way I do things. And I don't know what they want, but we're going to do everything. So I don't have an angle here. So I got to find, and I'm going to use sine. Well, wait a minute. Sine Oscar had, and I've got the opposite, and I've got, so that works. Sine of theta is equal to Oscar had 46.2. And I'm going to divide by the sine. Divide by the sine. Theta is equal to, bring this up, the inverse sine of 19.1 over 46.2. Now make sure that your calculator is in degrees, because we're not in 9.5. So that's going to be 19.1. I'm just using my calculator on my phone. I'm getting tired of switching over. So 19.1 divided by 46.2. And I'm going to take the inverse sine of that, inverse answer, and close parentheses. It gives me 0.4262. Oh, it's not. Let me check to see my mode. I'm in radian mode, dadgummit. I didn't know my phone was in radian mode too. All right, second entry. Now hit enter. 25.23 degrees. Is that what y'all got? So 25.23 degrees. Okay, now somebody subtract that from 90, and that's angle B. Oh gosh. I'm about ready just to quit. 90 minus 25.23. That's not going to work. Well, 64.77. 64.77 degrees. And now all we got to do is use the Pythagorean Theorem, and that's going to be 46.2 squared minus 19.1 squared, and that's equal to B. So I'm going to take my handy dandy calculator and I'm going to do second square root parentheses 46.2 quantity squared minus 19.1 quantity squared, close parentheses. I got 42.07. Y'all tell me if that's correct or y'all got that. Yes, no, maybe. Anybody? Have y'all left or what?
No, I got that.
Thank you. I appreciate it. Y'all just not talking to me today.
They're in the chat too.
What?
They've been answering
Oh,
that too. So
okay. Thank you. Thank you. All right. So next one. And this is 9.423/6. And find the measure of the angle formed by the line passing through the origin and the positive part of the x-axis used to display. Okay, I guess. Okay, I'm just gonna draw a picture of what they've got here. Okay, they've got x is 3.6. So this is 3.6 and this is 8.7. Okay, I'm just going to do everything. So that means I want to get the angle here. Oscar had, well, I got to get my, yeah, let's go ahead and get our hypotenuse. So C is equal to the square root of 8.7 squared plus 3.6 squared. So let's take our handy dandy calculator. And I'm going to, and I'll just show you that I'm using my phone because I don't want to have to go back and forth. So 3.6 squared. Well, I can't type either. 3.6 squared plus 8.7 squared equals, and raise that to the 0.5. I got 9.42. What'd y'all, or 9.4. What'd y'all get?
I got that.
Okay, now Oscar had sine of theta is equal to Oscar had. So theta is equal to the inverse sine. Okay, so I'm going to divide 8.7. 8.7 divided by 9.4. And I'm going to take the inverse sine of that. I got 67.7 degrees. Actually, it's close to 67.8. Therefore, we'll call it phi is equal to minus 90, 22.3 or 22.2 degrees. And if you can do this to a triangle, then you've got 9.4 under your belt. I mean, if you can fill out everything, then you're good to go for 9.4. So let's do another one. Let's see how many we got left. I got a few minutes left. So that takes care of that one. Let's see if I got the angle right before I move on. 67.8. Okay, I probably got a rounding error. Okay, they got 67.5. Now, what if this happens to you on a test? On that, I would probably be okay with it. And I'd probably, see me after class if you got one like this, and I'd switch it out. All right. So that takes care of that one. 9.439/9. We did that one the other day. Set them equal to each other. Okay, you got 2. I'll start this one, but I'm not going to do it all the way. You got 1 and you got 2. X and 8 and 2050 and 1110. Okay, so I'm trying to find H, and I've got something here and something here. So it looks like to me we go with the tangent. Oscar had a hunk of apple. So tan of 2050 is equal to Oscar had a hunk of apple. And over here, the tan of 1110 is equal to H over X plus 148. Solve these for H and then set them equal to each other. So I'm going to multiply, so this will be tan of 1110 times X plus 148 is equal to X times the tan of 2050. And solve that, and you'll get X. And then after you get X, you can find H. What is tan of 1110 and tan of 2050? What are they? They're just plain old what? Starts with
Decimals.
a D. Decimals. And what do you do with those decimals if you got them in a pre-algebra problem? You just distribute them. So turn that into a decimal and distribute it. This one just turns into a decimal, and then you can combine like terms. Just trying to get to as many questions as I can. That's why I'm not. And I've got like 6 minutes. Next. That takes care of that one. 9.441/10. Starting to run together. My eyes are starting to cross. To measure a stone face carved on the side of a mountain, 2 sidings. Okay, that's the same question that we just did. That question is just like the 2 triangles. Okay, I'll draw it for you. Here's a stone mountain. And you got to carve in 2 sidings. To measure a stone on if the angle of elevation to the bottom of the face is 36 and the angle of elevation to the top is 39, what is the height of the stone face? Okay, 750 feet from here. Okay, I'm looking. To measure a stone face carved, okay, let's say that this is the carving. I'm thinking of Stone Mountain is what I'm thinking of. Let's say that's the carving. Okay, and they give us an angle here of the angle to the bottom of the face is 36 degrees. And the angle to the top is 39 degrees. Okay, you still got two triangles. You got one triangle that looks like this. You got another triangle that looks like this. 36. Looks like to me you're going to set them equal to each other again. Okay. So that's another one. And I've got time probably for one more. I'm going to try to go over one that I haven't gone over before. Let's see. This is 9.441/10. Okay, that's the same one, so I'm going to kind of duck out of that one. Next, 9.448/12. Okay, a plane flies 1.4 hours at 110 miles per hour on a bearing of 30 degrees. So that's 30 degrees. He's flying that way. It then turns and flies 2.5 hours at the same speed on a bearing 120 degrees. How far is the plane from its starting point? Okay, well, this is not difficult. You just got to use a little bit of geometry where you learn the complementary angle and supplementary angle. Okay. I got an angle going this way, and this way. And this is 30 degrees. And this is, we know that that's 90 degrees. So this is what? 30 from 90 is what? So that orange angle right there is 60 degrees. And we know that the plane is 1.4 hours times 110. So what is 1.4 times 110? Well, I'm fixing to do it. 1.4 times 110. That's 154. So this distance right here is 154, whatever, feet, miles, whatever. Now I've got this angle, excuse me, I've got this angle right here, and that little man is standing right there. So that's the hypotenuse, and this is the adjacent. They need to know this right here. So Oscar had a hunk. So that would be cosine of 60 degrees is equal to a hunk. So multiply both sides by 154. A minute. Multiply both sides by h. So h is equal to 154 divided by the cosine of 60 degrees. So 154 divided by the cosine of 60 degrees. I got 308. Let's see, 308. Okay, then I assumed wrong on the 90 degrees, evidently. Okay, they got 308, 306. Huh. Well, that, I'll have to check on that one. Did they use what I used on the bottom? Hold on. Okay, I see what they're doing. That, oh, me, 30 degrees, 30 degrees, there's a 60. Just give me a second, let me see, because I think measures of ACB, that's your 90 degrees. It should be your 90 degrees, yeah. We're going to leave that one. I'll go over that one Tuesday. All right, let's go ahead and shut her down. And I'm going to turn off the recording.